another famous mathematician, and this is the thing he is most famous for. Euler is probably way more famous for some other math things. E is just one of his minor accomplishments.
That was exactly 400 years ago.
Thank you. Very.
Whoa.
Yeah. All right. 400 years ago. All right. So, John Napier, actually, he was an astronomer guy trying to do calculations about how far stars were away with these gigantic numbers, and he was looking for an easier way to make calculations simpler, so he didn't have to do multiply and add and subtract with these gigantic numbers. So he was trying to find a way to make computations easier. He actually developed one of the first actual mechanical devices. It was called Napier's bones. So there's these rods, and I've never seen that work, but you could match numbers up, and it made multiplication simpler for you. It was like the precursor to a calculator or something. And he discovered logarithms because he wanted to make computations easier. Now, I can't show you why that made computations easier yet. I will show you, but we can't at this point do that. But he was playing, if we look at what we did the other day, our exponential functions, okay, what restrictions did we put on what the base can be?
Nothing below 0.
Okay, so it had to be greater than 0, and it couldn't be 1. Okay. I want to also note a few things here. What can x be? Yeah, x can be any number. X is all real numbers. Okay. But I do want to point out, what can y be? If the base is always positive, will y ever be a negative number then? No. So y is always going to be above 0 as well. Okay. What they decided to do to get a logarithm is they said, hey, let's figure out what the inverse of an exponential function is. So logarithms are the inverses of an exponential function. And my question to you is, how did we find an inverse? What did we do to the coordinates? We switched the x's and y's. Yes, we did. So, it's a little bit tricky for how that happened, so we got to look at that a minute. I'm going to actually do this with numbers in it because I think it's a little less confusing than it is with b for a base, so I'm going to do this with a number in it. So suppose he was trying to do 5 to the x, and he wanted to do the inverse. And you said switch the x's and y's, which is right. He did. But then if you remember when we were finding inverse equations, the second step was you had to solve for y. How do you solve for y when it's in an exponent? Do we know how to solve for the exponent? But if you y root it, that makes the y go away, but that hasn't solved for y. Because, like, I can't divide 5 over and get y by itself. I have to get y by itself. Okay? It couldn't be done at that time. You're right. So, mathematicians, when you can't do something, you invent a whole new notation and a whole new system and prove it to be true. So, he said, okay, since I don't have a way to solve that, I'm going to invent a way to solve it. And so I'm going to solve it by calling it, and I don't know the Latin of why he named it logarithm, but, okay, I'm going to call it a logarithm, and I need to keep track of what the base number was. So he said we're going to write the little base number down here at the base of log. So it has to be the log of something. What's the only thing left I haven't used? X. I have not used X yet. It's a regular. So let me give you an example here where you can connect the numbers. Would you all agree that 8 is equal to 2 cubes? Okay. If you were to change that and write it in logarithmic form, if you were to write it as a log, a logarithm solves for an exponent. So therefore, I would say 3 is the exponent. I would say 3 equals
Log of 2
okay.
times 8.
And it's read log base 2 of 8. So I keep track of my base, and it equals the 8.
Where'd the 3 come from?
So 3 is the exponent. Logarithm.
Sorry, I was just asking.
Okay. The key thing, log solve for exponents. Logs represent exponents. You see a log, it's another way to write an exponent.
So what's about log and the view? How do you, I don't get it.
Give me a second here. Trust me, this is on your journal. Super duper important. When you see a log, think this is an exponent, it's an exponent, it's an exponent. Because I didn't want to take time to switch tools.
Come on, let's do it.
No,
Strawberries.
we don't have
It's YOLO, you gotta do it.
Okay? So, let me prove to you that you already know this. You just don't realize it. That was one way to write as log. Suppose I gave you log base 5 of 125 equals 3. Turn that back into an exponent. What would be the base?
the base would be 5.
The little subscript is the base. So 5 is the base. What's the exponent?
3.
The log equals the exponent. So the 3 over there is by itself. That's the exponent. So this would say 5 cubed equals 125. Is that true? Yeah, it is. 5 cubed equals 125. It's not so bad.
Wait, so that's log?
You don't know.
Oh, no, those are crap. Those are You always show us easy ones. Then it gets really complicated. You're gonna have a problem with
Okay, so on your journal, down toward the bottom, I think, of the first page, it asks you to show the relationship between exponential form and logarithmic form. It's down where I have you list formulas and stuff. I don't exactly know the number. So if I tell you exponential form is y equals a base to the x power, rewrite that as a log. What would it say?
It would equal
So your x is the exponent. X equals
log b
log base b
y.
of y. Yeah. That's if you want a visual way to know how to switch the numbers around, that's it. Okay. Notice then the rules about the base that we just had up here. Base had to be greater than 0 and couldn't be 1. Well, it's going to be greater over here. It's the same thing. The base has to be greater than 0 and it can't be 1. Because if it's that rule over here, the base can't change over there. So you can't have log of base negative 2. You can't do something like that. You can't have a log base 1. Okay, so over here, so what we've done then, by doing the exponential or doing an inverse, we just switch x and y coordinates. So if we get the graph today, which we may or may not, all you're going to do to graph these things is take the t-table you just did yesterday and switch it. Switch your x's and y's, just like we've done when we graphed x squared and square root. You switch the x and y's to the opposite side of the t-table. That's all you do to graph a logarithm. You switch the x's and y's to the other side. It's that simple. They really aren't that bad. It just plays with your brain because it's different and it looks weird. You're reading this weird log-based thing.
How do the logs help? How they help the John Napier person?
Okay, I don't know enough yet that I can show you all that. We'll get there. But we don't know enough yet. Sorry.
Why does everyone say logs are so bad?
Because it just plays with your brain a little bit. But we're also on day 1 too. Log, so. Alright, so what I'm going to ask you some problems you're going to be asked to do, what's log base 3 of 81? Okay, this is where your pink sheet may help you. Okay, if they ask you that, they're just asking you, what power do you have to put on 3 to get it to be 81? Because the answer to a logarithm is the exponent. So 3, maybe I should have done the smaller one. Do 9. Log base 3 of 9. That'll be nicer. 3 to what power makes 9? 3 squared is 9, isn't it? So therefore the answer here is 2. When you're evaluating a log, you just have to ask yourself, what power would I use? So what if I said, what's log base 2 of 8? 2 to what power makes 8? 3. 2 cubed is 8. Okay, now, if I wrote that out, I could have, I want you to see this connection. 8 is 2 cubed. So what happens when you have a log base 2 and an exponent with a base 2? We just said the answer is 3. What happens when you have those two together like that? They cancel each other out and you get 3. So if I went crazy on you and gave you a log of 175 to the 21st power, what would you tell me the answer is? 21. If you got the same base, they're inverses. They cancel each other out. A log and an exponential function take each other away. And so you would just get 21. So suppose I said then, what's the log base 7 of 149? What do you know about 49? It is 7 squared. So that would be 1 over 7 squared. But if I could get it up top, it would cancel. Okay, you're right. So she said bring it up. That'd be 7 to the negative 2, wouldn't it? So therefore, what's the answer? Answer's negative 2 then. Got the same bases here. Answer's the exponent. Got negative 2. All right, 52,000 more. As you can't tell, I'm going to beat this into you. What if I gave you log, what is another number? Log base 11 of the 5th root of 11 squared. Here's your exponent rules again. They never go away. Okay, how do you write a root as a power? 2/5, isn't it? So therefore, what's your answer? 2/5. Okay, so are we getting the pattern that comes in this? Yeah. Okay, one more. Suppose I said let's do log base of 13 of, yeah, I was going to use 169, but I think I want to make it the 7th root of 1 over 169.
Fun.
What would you do with it? Okay, well, let's do that in steps. What do you know about 169? He knows his powers of numbers, for one thing. 13 squared is 169. Okay, so if I bring the 13 up, what's it become? It becomes 13 to the negative 2, and it's in a 7th root. Okay, it will in a moment, but I got to get rid of the root. How do I write the root as an exponent? What fraction is this? That'd be negative 2 over 7, wouldn't it? So therefore, what's the answer? Negative 2/7. They cancel each other. So if the base is 13 on the log and the base 13 on the exponent, same base, they cancel each other out.
Well, I still don't get the point of it.
I can't. We just got to develop more stuff before I can do this. Right now, you just have to believe me.
What's the point of this is today?
Today is to learn how to work with a log period. Today we are just learning how to manipulate logs. Then we'll learn about what you do with them later. Today is just how do I do logs. Pure and simple. Okay, there are 2 special logs out there in the world that are used more than any other. Your calculators, these newest calculators, now have all logs built in. But it used to be your calculator would only have these 2 special kind of logs on it. And that would be the 2 that are used the most. We found ourselves using log base 10 more than any other. Because, guys, when you want to write really big numbers, like 2,300,000, didn't we change them to scientific notation? And what base number do you use in scientific notation? 10. So they found themselves using 10s all the time because of scientific notation. So mathematicians, being lazy, went, I don't want to have to write the little 10 all the time. So So they decided they weren't going to write it at all. So if you see a log and it doesn't have a base number, it means it's a 10. It's just the whole world knows it's 10. So you'll see a log key on your calculator. Actually, your log key pops up a log and it gives you a place to type the base. If you don't type a base in, your calculator will assume you mean it to be 10. Everybody knows it's a 10, even the calculator. Okay. The other one that's used the more tons is base E. We love base E logs. Okay, and once again they went, I'll have to write the little E all the time, it's slow. They went another way. Okay, I should have told you this. These logs are called common logs because they were very common. These logs with base E are called natural logs. Why? Because they're using E, the nature number. Okay, so they went, need another way to write this. So, those of you in French or Spanish should understand this. They called them LN. They write LN, natural and log, but the log comes first. It's logarithm natural because in those languages the adjectives come after the nouns. Yeah. So it's logarithm natural. So you'll see you have an LN key on your calculator. You do. You do. Okay, so tell me, if you see a problem where I ask you natural log of e to the 8th, natural log is a what base? E. So I have the same bases? The answer would be 8. Natural log and an e cancel each other out always. You see a natural log and an e together, boom, they take each other out. They're inverses. Okay, same way if you see a log, LOG log, with a base with a 10 on it, and there's no base on that log, you know it's really a 10. So what's the answer? Answer is really just a 9. Oh boy, we are in serious trouble. We're behind, yeah. We're way behind. I needed to get through one more thing for sure. The graphing I can put on either day, but I really wanted to show you how to solve an equation. We got 30 seconds or 1 minute and 30 seconds? 30 seconds. Okay, your next assignment's going to be long.